Remember that with questions like 1, 2, and 3, you can graph those in your calculator after you graph them or before, doesn't matter, to double check that your graphs are correct and your intersection point is correct. Regardless of if you put it in the calculator, you still have to put it on here. So for the first one, we're going to start at positive 3. And then use our slope 1/3. Go up 1 to the right 3, down 1 to the left 3. And then for the other one, we're going to start at positive 1. The slope is negative, so we're going to go up and to the left, and down 1 and to the right 3. And you're looking for where do these intersect? Okay. So the intersection point would be right here at -3, 2. So you would write that as an ordered pair. Questions on that one? Aaron. So if your lines do not intersect at all, they don't touch each other, that is no solution. If the lines overlap one another, that is infinitely many solutions. With number 4, we have to get these both in slope-intercept form before we can graph them. So I'm going to solve both of these at the same time. Subtract 8x. So that we have 3y equals -8x plus 12, and 3y minus 8x minus 9. Then you have to divide everything by 3. So for this first one, it would be y equals -8 over 3x plus 4. For the second one, it would be y equals -8 over 3x minus 3. Graph both of those. So if I'm graphing the first one, I'm going to start at 4. My slope is negative, but I can't go up, so I have to go down 8 and to the right 3. And then the other one would start at -3, and we'd go up 8 and to the left 3. So these two lines would not intersect, so your solution would be no solution. Questions about that one? We're going to move on to number 9. The biggest thing with these is make sure whatever it says, that's what you're doing. If it says solve by graphing, you shouldn't be solving by substitution or elimination. If it says solve by substitution, you should be solving by substitution, not elimination, not graphing. And then the same thing with elimination. With number 9, you are in the substitution section, so we have to solve by substitution, not elimination, not graphing. Look for a variable that's by itself, or almost by itself. Maybe it has a negative instead of a positive. If it's not solved already, you have to solve it. So we would subtract 5x to the other side. We have negative y equals negative 5x minus 19. But y isn't by itself. We have to get it by itself by dividing everything by negative 1. So we now have an equation that is solved for y. And we're going to take that equation and substitute it into the other one. Again, if the arrows help you, do that. So for this second equation, we have negative 5x plus 8 times the equation we just found. 5x plus 19 equals negative 23. Then you would solve, distribute. I don't remember what that is. Combine your like terms, your x's. So this would give us negative 35x plus 152 equals negative 23. Subtract 152 to both sides. And then divide both sides to find x. Once you find your x, you have to go back and put it in for y. It doesn't matter where you put it. This would probably be the easiest one though. So put the 5 in for x and solve. Oh, sorry. This shouldn't be a negative 35. Afterwards, yep. Once you have your x and your y, put those together as an ordered pair. Negative 5, negative 6. Questions on that one? So 11 on this one, and then we'll do 14 on the next one. If you have the same variable equal to two separate equations, you can set them equal to each other. And after you set them equal to each other, you can solve. Move your constants to one side, your variable terms to the other. In the way I moved everything, I got 0 equals x. 0 can be an answer, that's fine. Then you would put that back in and solve for y. And then once you have your two, put them together as ordered pair. Questions on that one? Once you have written that down, turn to the next page. We're going to do 14. Is still a substitution one. This one is nice because it gives you what y is already, so really we just have to find x. We're going to put -2 in for y. And then solve. So when you put it in, don't forget the negative that was already there, because it'll change to a positive, but if you don't put that in, it won't change. At the end, divide by a -1. And after you have your x, you have your y already, so you can write that as an ordered pair. 8, -2. Did we have any elimination questions before we move on to the word problems? 15. 15. Okay. So again, if you're asked to be solving by elimination, you shouldn't be solving by substitution, even if you see something that would be nice as substitution. So for elimination, the rules change. Think about your different rules. For elimination, we are now looking for common coefficients. Here we don't have that, but we could change this to be that by multiplying this first one by 6, the entire equation by 6, not just one piece, so that it changes to 18x plus 6y equals negative something. 126. And then if you're not sure how to eliminate, you could put this in the calculator, double check yourself. -6 plus 6, -6 minus 6. See which one would eliminate the other. I put way too many signs. The first one eliminated it. I put in something wrong for the second one. So if I add the two equations together, they should eliminate. So -4 plus 18 would give me 14. -6 plus 6 is 0. 0 plus -126 is -126. And then divide by 14. Once you get that x, go back and put it in for one of your y's. Doesn't matter which one. So let's say we do the first one. And we would be solving for y. So add 27 to both sides, so that y equals 6. And then your ordered pair would be -9, 6. Questions on that one? For 21, we already have common coefficients or similar coefficients, the -2 and the 2. So again, if you're not sure, you can put it in your calculator. -2 minus a +2, -2 plus a +2 is similar to the one we just did. So we would be adding x plus a -5 is just x minus 5, so -4x. Our y's cancel. 11 plus a -23 is just 11 minus 23. And then we can solve for x. And then we can go back and solve for y. I'm going to put this in. I don't know if we'll have enough time to finish it. We would subtract 3 and divide. -4 would be our answer for that. Okay, and then when we get back, we'll do the 2 word problems. And then you guys will take your quiz. Remember with all of your word problems, after you set it up, you have a choice of how you want to solve it. Graphing, substitution, elimination. Circle, underline, highlight, anything you find that is important. If you see numbers, those are usually important. So for this one, 2 chicken sandwiches, 3 bowls of vegetable soup, 4 $16.50, all of those things are important. 1 chicken sandwich, 3 bowls of vegetable soup, and $9.50. Those are all important. And then it's asking, what is the cost of a bowl of soup? That tells us what we don't know. So look at the question because that'll help you define your variables. Those two things go hand in hand. So cost of a bowl of soup is going to be one of our variables. It doesn't matter what variable you choose, E, S, X, whatever you want, letter you want. And then be specific, this represents the cost of a bowl of soup. And then we need to define the other variable, even though this question is not asking about the other one. So C for chicken sandwiches, cost of chicken sandwiches, or of one. After you define your variables, look at the numbers given. If you are given 6 numbers, like we are here, you're going to use each of them in the format ax plus by equals c, but these are going to be your variables instead of x and y. So it would look something like 2c plus 3b equals 1650, and 1c plus 3b equals 950. Some of your problems will be set up to graph nicely. Some will be set up to do substitution nicely. If not, elimination works well for all of your word problems. This one, elimination works well especially because we have common coefficients already. So if we were to eliminate our b, we could subtract. 2 minus 1 would just give us 1. 1650 minus 950 would give us 7. Be specific with your labels. If we're looking for costs, your label should be dollars or cents. If we're looking for a number of whatever, or number of points, number of whatever, make sure you put that label. Unfortunately, we solved for C, but we needed to find B, so we have to go back and find what B is. So put C, the 7, in for one of your equations. Does not matter which one. And solve for B. We would subtract 7 and divide. Divide that and tell me what you get. So think about your problem. You're looking for cost. So what would I put as the cost? 83 cents, 0.83, any of that, yep. So if you want to put it as 83 cents, you do that. If you want to put it as $0.83, you do the same thing. Just make sure your answer makes sense. If we're looking for costs, usually you only have 2 decimal places, not more than that. So I wouldn't keep putting 3 repeating. Questions on that one? $25 is weird because it's really just math written into words. It's not a real word problem. So for this one, important things, we have 5 times Jasmine's number minus 3 times Josh's number is equal to negative 16. We're going to do that here in a second. And then 4 times Jasmine's number plus 5 times Josh's number is equal to negative 35. We need to find the value of both of their numbers. So defining their variables, it would just be Jasmine's number and Josh's number. Pick 2 different variables. They both can't be J. So let's say I call this one A and I call this one H. So because this is really just math into words, you're just going to look at what it says and write that as an equation. 5 times Jasmine's number, so 5 times A, minus 3 times Josh's number, so 3 times H, is equal to negative 16. There's so much right. The second equation would be very similar. 4 times Jasmine's number, so 4 times A, plus 5 times Josh's number, so 5H, is equal to negative 35. I'm not going to solve this one, because you can choose which method you want, substitution, elimination, graphic. Are there any others we want to see set up? Not solve, but set up on this page. Okay. If we don't have any other questions, go ahead and clear off your desk. Put your cell phones in a calculator pocket. Grab a calculator.